All right, so again, we're talking about scale drawings. On the left side, we've got a scale drawing of a school bus, a quarter, and subway lines, a map for Boston. And then on the right, we have pictures of what is not a good representation or not a scale drawing of a school bus, a quarter, and the maps, the subway line maps. So by these examples of what is a scale drawing and examples of what is not a scale drawing, what do you think the definition of a scale drawing is supposed to be? Anybody have an idea? Vincent? Huh? What do you think, Ian?
It has to be the most accurate thing possible.
Okay, it has to be accurate, right? An accurate representation. What else do you think, Michael?
The exact shape of the object.
All right, the exact shape. So it has to be exactly the same shape. Does it have to be the same size? So do you think that's the size of a school bus in real life? Can we fit a school bus right here? No, that's not even the same size as a quarter, right? A quarter is going to be a little bit bigger than that, than what's on your paper. So does it have to be the same size? No. But does it have to be exactly the same shape? Yes. So what this is going to be, and I love the word that somebody used, that you used, accurate. It has to be accurate. Okay, it has to be exactly as it's supposed to be. These are not accurate drawings, okay? They're not even a good representation because it's not a perfect circle or things of that sort. So what it needs to be is an accurate representation, okay? Proportional is also a key word that you need to know. It has to be accurate in its shape, and it has to be proportional in its size. So it could be smaller or it could be larger. So a scale drawing, it's a larger or smaller accurate representation of an actual item, right? An actual picture, an actual coin, an actual school bus, okay? It needs to be proportional in size. So that means that you've got that scale factor. Remember we talked about scale factors in the last unit? Scale factor, aka the K factor. Okay, we called it that K factor. It's a factor that you are multiplying by. Okay, so scale factor means that you're creating this proportional relationship. That means if I take an item and I multiply every single one of its dimensions by a factor of K, then it's going to create a proportional shape. Okay, something that is an accurate representation. It looks exactly the same thing, but it's on a smaller scale or a larger scale. Okay, we use these often, especially when you have things like maps. Okay, way back in the day, you didn't have cell phones. Okay, you didn't have cell phones that were able to tell you how to get from point A to point B. You had to use, well, for me, we used MapQuest. So I still didn't even have to use the big old maps. I just used MapQuest and it would tell me the directions. Okay, but back in my parents' day, they actually had to have a foldable map. And then they had to look at the scale drawing and they had to be like, okay, hey, for every single little inch on this map, that's representing 50 miles. Okay, because they have to be able to fit an entire city or an entire state on this large piece of paper to be able to route how you're going to go. So it's really a real usable concept, these scale drawings. When buildings are created, when we make buildings, you have to make scale models of those buildings first. They go through so many different scale models before they can come up with what the actual building's going to be. Okay, any house that you live in or an apartment that you live in fact, right now there's apartments that are being built right down the road from our school. Before they can start building them, though, they have to be able to follow what's called a blueprint. Anybody ever hear of the blueprint? Okay. So blueprint is basically that layout of what the apartment building is going to look like, right? And I don't know if any of you have ever gone with your parents when they look at an apartment. They might not go into the apartment, but they might show them what the blueprint is going to be so that you get an idea. Oh, hey, you know, this is the laundry room. Here's where bedroom A is, bedroom B, bedroom C. Oh, they have an upstairs. You know, they give you that blueprint. Even when you go for a home, when you're building a new home, you have to look at the blueprints before you actually go into the actual homes. Okay, so these are things that are used all the time. Like I told you, this is a real life math concept. These have real life applications. Out of all the math that you're going to be learning, this is the stuff that's very, very relevant to every day. Okay, so for our scale drawing representations, we need to identify that scale factor so we can figure out what we are changing our shape by. So if we're taking a look at problem number 1, we've got this shape. It's a quadrilateral. Okay, it's 4 sides. Shape ABCD, or quadrilateral ABCD. And we've got a scale factor of 4. That means that we are going to take each one of these original dimensions and we're going to multiply it by a scale factor of 4. Okay? You could also take the points that they're located at and multiply them by a scale factor of 4. And that would help you out. Okay? So what we're going to focus on for right now, we're not going to focus on drawing line segment BC or DC, because I don't want to get into the whole idea of how to calculate those measurements. But what we are going to focus on is how to calculate going from A to D and A to B. We're just going to focus on those 2 line segments. Okay? So for here, who can tell me how big is line segment AD in units, square units? 1, right? So we're going to go ahead and write a 1 off to the side here. What about from A to B? How big is that unit? 2. Okay, so we've got AD and AB have units 1 and 2. So what we're going to be doing is we're going to multiply by a scale factor of 4, and we're going to redraw those lines. So if I multiply this by a scale factor of 4, what is 1 times 4 going to give me? 4. So starting somewhere on my paper, I'm going to draw point A, and instead of going down 1 unit, I'm going to go down 4 units. 1, 2, 3, 4. Okay, now same thing to go from point A to point B. I need to multiply this by 4, and that's going to give me how much? 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Oop, I should have started 1 over. We'll go 8 right here. That's going to take me to point B. Okay, and then this is to point D. This is 4 units. This is 8 units. Okay, and then somewhere down along the line, we'll have point C. But we're just going to be mapping these 2 lines, just because I don't feel like having you guys focus on diagonals. You won't have to do that on your test either. But if they're giving you dimensions, so let's say that we have off to the side, I've got the following triangle. Let's say that this is 3, this is 6, and this is 12. 3, 6, and 12. And now I'm telling you that your scale factor is 1/3. If you've got a scale factor of 1/3, what do you think is going to happen? So here we had a scale factor of 4. What happened to the shape? Did it get bigger or smaller? It got bigger. What do you think is going to happen if we have a scale factor of 1/3? Why do you think that is? Because it's not a whole number. Okay. Well, what if it was 5/2? If the scale factor was 5/2, do you think it would get bigger or smaller? Bigger. Okay. But that's not a whole number either. Right? So it's not about being a whole number. It's about whether it's bigger than or less than 1. If my scale factor is 1, is that going to change my shape? If I do 1 times 1, is that going to change anything? If I do 4 times 1, is it going to change anything? 2 times 1, is it going to change? No. So if my scale factor is a 1, it's not going to change anything. But if my scale factor is bigger than 1, it's going to increase the shape. If it's smaller than 1, it's going to decrease the shape. Okay, we call those enlargements and reductions. I want you to make note of that right down here. If your scale factor is greater than 1, then it's going to be an enlargement. Right? It's going to get bigger. If the scale factor is less than 1, then we call that a reduction. Your scale drawing will get smaller. So what we have pictured up at the top with the school bus and the quarter and the map, those are all called reductions. Okay, they had scale factors that were less than 1. They reduced the size in order to be able to draw an accurate representation of a larger item. So let's take a look here. Again, we're talking about a scale factor of 1/3. That's a value that's less than 1. So these numbers should get smaller. These numbers should go ahead and get smaller. So what we're going to do is we're going to take each one of these sides and we're going to multiply them by 1/3. Even though it's multiplication, it's still going to get smaller because it's a value that's less than 1. What is 3 times 1/3? What do you think that's going to give us? 1. Right? 3 times 1/3 is just going to give us 3/3, which is 1 whole. What do you think 6 times 1/3 is going to give us? Okay, Ron? 2, right? 6 times 1/3 just becomes 6/3, and 6/3 is going to give us 2. Okay, if we do 12 times 1/3, start getting the picture. 12 times 1/3 is going to become 12/3, which is what, guys? 4. 12/3 is going to give us a 4. Okay, so our scaled drawing is going to reduce its size, where this is a 1, this is a 2, and this is a 4. That becomes our new scaled down drawing, our reduced drawing. Take a minute to go ahead and get that copied. All right, let's go ahead and turn it on over to the back. So taking a look here, triangle Z is a scale drawing of triangle M. So here we have triangle M, and I don't know if you can see these very clearly, so let me go ahead and rewrite what those sizes are. This is supposed to be a 4, this is supposed to be a 7, and this is supposed to be a 10. What we're wanting to know is which one or all sets that could potentially be scale drawings to this, meaning that they are proportional to this. Okay, so what we want to figure out is how can we get from here to here by a scale factor. Okay, so what we're going to do is we're going to set up a proportion. So I'm going to do the first one with you guys. I'm going to do the first one with you. We're going to pick 2 of these, 2 sides. I don't need that. We're going to pick 2 sides, and comparatively, we're going to use the same 2 sides here. Now notice, this is the smallest, this is the middle, and this is the largest. So when I'm making a comparison, I have to compare it also to the smallest, middle, and largest. I have to compare respectfully. Okay? So if it is proportional, then that means when I take my scale and divide it by my original, it should be the same throughout the entire problem. Okay, so let's focus first on the smallest. When we focus on our smallest, and I'm going to put a line through here. Which one of these numbers is our smallest up here? The 8. So we're going to take the 8 and we're going to divide it by the 4. And what is 8 divided by 4? 2. Okay. Now we're going to focus on the middle. The middle value here is 11. What's the middle value for up here? 7. What's 11 divided by 7? If we do 11 divided by 7, is that going to come out to 2? No. 11 divided by 7 is going to come out to 1.57. It's going to keep going on. Okay, so do you think these are the same? No. So this is not to scale. It's not a scale drawing. So option A, not going to work. Okay, so now we're going to go to option B. Let's take a look at option B. Option B, what's the smallest side on option B? 10. So we're going to take 10 and we're going to divide it by 4. 10 divided by 4 is going to come out to 2.5. The middle, right? This is the small, this is the middle, this is the large. We're going to take the middle. The middle is 17.5. We're going to divide it by the 7. And that comes out to 2.5. Do you think I'm done then?
No.
No. I have to check all of them, don't I? Because there might be 2 of them that come out the same and 1 that does not. It's very possible. Okay? So we need to check the 25. We're going to do the large. 25 divided by 10, but that also comes out to 2.5. So this is a scale drawing, because all of them come out to the exact same scale factor. Okay? So what I want you guys to do is you're going to check C, D, and E, because there's still some more that are actually scale factors. So you check C, D, and E on your own. You're going to take the smallest value on your new shape, and you're going to divide it by the smallest value on your original shape, and then you're going to do the same thing, middle divided by middle, large divided by large. All right, if we look through this and continue working these out, if we were to progress, for the very first one for C, we would have to do the smallest, which is 6, divided by the smallest on our shape, which is 4. If we do 6 divided by 4, that's going to give us 1.5. Then we're going to do the same, the middle one. The middle one is 9. We would divide that by 7, but when we do 9 divided by 7, we don't get 1.5. We get 1.2857. It just keeps going on. So 1.28, that's not going to work. They are not the same. Okay, they're different, so that is not a scale drawing. We don't even need to continue. Once you find that they aren't the same, you can move on. Cross that one off. We're going to go on to D. We do the same thing for D. Again, we know 6 divided by 4 is going to give us 1.5. Okay, then we're going to do 10.5 divided by 7. 10.5 divided by 7 is going to come out to 1.5. And then we're going to do 15 divided by 10, and that's going to come out to 1.5. So that does work. So there is an option of a scale drawing. And then we'll go on to the last one. Okay, the last one has us doing 8. 8 divided by 4. 8 divided by 4 is going to come out to 2. Then we're going to do 14 divided by 7. That comes out to 2. Then we'll do 20 divided by 10. That also comes out to 2. All of those work, so E is also an option. So we have option B, D, and E are all representations of possible scale drawing measurements. Okay? Again, it has to work for all of the sides, all of the measurements in order for it to be considered to be a proper or proportional scale drawing. Okay, any questions? All right, let's take a look at the next one down here. So again, I told you guys before, blueprints. With blueprints, they are basically like a map, a scaled down map drawing of maybe a room or a building, things of that sort. Ezra, you don't need headphones on your head right now. Take them off. So builder is using the scale drawing shown to build a house. The figure below shows a blueprint of the family room. So it's just a rectangular shaped family room. So they're saying this is 5 centimeters by 3 centimeters. Is that the actual size of the room? No, a centimeter is small, guys. It's small, okay? So it's less than an inch here. You look at this. This is an inch. This side is centimeters. So if we're doing centimeters, each centimeter, 10 millimeters is considered to be 1 centimeter. So 3 centimeters is from here to here. That's it. That's not the size of a room, but that's just the size of the blueprint. Down here, it says that for every centimeter, it represents 3.5 feet. 3.5 feet. So for one of these, from this point to this point, that represents 3.5 rulers. Okay, so it's a much bigger shape or a much bigger size. So what we want to know is what is the actual length and width of the family room. So what is the actual measurement going to be? We want to know what is the perimeter of the actual family room and what is the area of the actual family room. Okay, so I'm going to go ahead and label this my length and this is my width. And what I want you guys to go ahead and do, identify what the length and the width is going to be of the actual room. Find the perimeter. Remember, perimeter means you're adding all the sides together. What does area mean we're going to do? Not add. Perimeter means you add. Perimeter, you're adding all 4 sides. Area means you're just multiplying the 2 dimensions. Area means you're multiplying the 2 dimensions. Go ahead and answer A, B, and C. Find what the real measurements are. What will the perimeter of it be? What will the area be? All right, so the length on our blueprint is 5 centimeters. What will the actual length be? Angel, what will the actual length be? If our length is 5 centimeters, what is the actual length going to be? You have to multiply 5 times 3.5. Good. So when we're doing the length, we're going to take the 5 and we're going to multiply it by 3.5. That's our scale factor. This is our scale factor. Okay, so 5 times 3.5, this is for our length, is going to give us what? 17.5, and it's for feet. This is measurement of feet, 17.5. Let's do the same thing, but now for the width. Our width measurement was 3 centimeters. What is the width measurement going to actually be? Vincent, the width. What is the actual width going to be? 10.5, because again, you're going to take what the original blueprint was, which was 3, and you're going to multiply it by that scale factor of 3.5. And that's going to come out to 10.5, and that's feet. Okay, so there are dimensions, our actual measurements. Now we want to find the actual perimeter. So again, guys, if you were to draw this out for perimeter, you are adding all the sides together. So I know that this measurement is 17.5 feet. I also know down here this is 17.5 feet. I know that the side measurements are both 10.5 feet on the right and 10.5 feet on the left. So for my perimeter, I'm just going to add all 4 sides together. So I'm going to take 17.5. I'm going to add 10.5. Then I'm going to add 17.5 and add 10.5. Okay, when I add all of those together, that's going to give me my area. What is the area of, or sorry, not area, perimeter. What is the perimeter of my living room going to be? 56. And that's feet. 56 feet. 56 feet. Okay, now for the area. Again, we're using the actual measurements. So for our actual measurements with area, you're just going to take that length, 17.5 feet, and you're going to multiply it by the width, which was the 10.5 feet. So we're just doing length times width. So we're taking 17.5 and we're going to multiply it by 10.5, and that's going to give us our area. What is the area? Go ahead. Good, 183.75, and this is feet squared. Area is always squared. So you're just multiplying those measurements for area. You're adding the measurements for perimeter. Okay? Any questions? I think scale drawings is a very, very simple concept. It's just taking a scale factor and either increasing the size by multiplying by a number larger than 1 or decreasing the size by multiplying by a number less than 1. Okay, let's go ahead and go to that last page. Okay, what I want you guys to go ahead and do is answer problems 1, 2, and the agree or disagree on your own. Questions 1, 2, and then the agree or disagree on your own. Question 1 says that you've got a school bus that has a scale of 1/2 inch for every 5 feet. 1/2 inch represents 5 feet. If the length of the school bus is 4.5 inches on the scale drawing, then what is the actual length of the bus? So 1/2 inch is going to represent 5 feet. You want to figure out what the scale factor is by taking what is 1 inch equal. Okay, if 1/2 inch equals 5 feet, what would 1 inch equal? And then use that to figure out what 4.5 inches is going to be equal to. You could also set it up as a proportion to solve. For problem number 2, 1 centimeter is 80 meters on a scale drawing. So if the actual width of a lake is 1,000 meters, then what is the width on the scale drawing going to be? So you're going to be working backwards this time instead of going forward. Okay, so you're going from the actual measurement down to the scale drawing instead of scale drawing up to a measurement. And then the last one, if you've got this original triangle, we want to know which one of these people is correct in their argument. Okay, person 1 says that scale drawing 1 doesn't belong because they said that they said only one of the measurements does not correspond proportionally. Person 2 says that scale drawing 3 doesn't belong because he says nothing is proportional. And person 3 says scale drawing number 2 doesn't belong because it's a reduction instead of an enlargement. So which one of these people, people's wrong? Who's wrong in their calculation? All right, let's take a look here. For problem number 1, it says a scale drawing of a school bus has a scale of 1/2 inch to 5 feet. If the length of the school bus is 4.5 inches on the scale drawing, then what's the actual length? The best thing I can tell you guys to do is just to set this up as a proportion. If you do a 1/2 inch, which is your scale, over your 5 feet, which is your actual, and then you set it equal to 4.5 inches over x feet. You can go ahead and do your cross product and solve. Then when you get x, that's your actual measurement. So all you would have to do is multiply and set up an equation. 1/2 inch times x is just 1/2 inch x. 5 times 4.5, that's going to come out to 22.5. And then you're just going to divide both sides by 1/2. And when you divide them both by 1/2, you're going to get 45. So it should have gotten 45 feet. Okay? Problem number 2. For problem number 2, a scale drawing of a lake has a scale of 1 centimeter to 80 meters. If the actual width of the lake is 1,000 meters, what is the width of the scale drawing? Again, you can set this up as a proportion. 1 centimeter represents 80 meters. So how many centimeters is going to represent 1,000 meters? Set it up. Centimeters over meters, and do your cross product. You're going to do 80 times x, which gives you 80x. Then you're going to do 1 times 1,000, which gives you 1,000. And then you'll divide both sides by 80. So when you do 1,000 divided by 80, you're going to get 12.5. So that's 12.5 centimeters. Okay, and then the last problem down here, they want to know who is the correct argument. So your correct argument is going to be both, well, actually, it's just going to be problem 1. Problem 1 is the only one that is the correct argument. Okay, problem 1 is the only, or no, not problem 1, person 2. Person 2 is the only one with the correct argument. Where they say that scale drawing number 3 is not going to work because nothing is proportional to the original, that's the only one who's correct. Scale drawing number 1 is proportional. It is a scale drawing. Okay? If you double each of the original measurements, 5 times 2 gives me 10, 4 times 2 gives me 8, 6.4 times 2 gives me 12.8. So scale drawing number 1 is a actual scale drawing. So person 1 is wrong. Okay? Person 3 is wrong. They said that scale drawing number 2 is not going to work because it's a reduction instead of an enlargement. But it's okay to reduce the size, right? We know that blueprints are all reductions of the size. So it's fine that it's a scale drawing that is smaller. If you take 5 and multiply it by 1/2, that gives you 2.5. If you take 4 and multiply it by 1/2, that gives you 2. If you take 6.4 and multiply it by 1/2, it gives you 3.2. So scale drawing 2 is a correct scale drawing. So person 3 is wrong. The only one who's correct is person number 2, who says that scale drawing number 3 is not going to be a scale drawing because nothing is proportional. Okay? All right. You guys yesterday, and here I'm going to stop the video.